Hi everyone, this video is going to review the functions practice number 1. Okay, question number 1 says, what are the 5 ways that a function can be represented? So I put some pictures here to help us. The first way is with a table. The second way is ordered pairs. Sorry, that's an R. Letter C, we're going to go ahead. The third way is a graph. The fourth way, this is called mapping. And finally, we can represent a function with an equation. And you can have this in any order on your paper. Okay, number 2, for each question on this page, we're going to decide if the following are functions. So that's yes or no, and then explain. So we know that in order for something to be a function, the important part we want to look at is the x. So I'm going to go ahead and cover this up, and I see there is only one line coming out of each number here in the mapping. That means that the answer is yes, it is a function, and that's because x does not repeat. All of the x values are different. Okay, we're going to keep doing the same thing. These are our x values. I'm going to cover the y. There is only one line coming from each of the x values. So that means the answer again is yes, because x does not repeat. Number 4, I'm covering up the y again, but this time I see 1, and this -6 has 2 lines coming out of it. And each line goes to a different y value. That means the answer to this one is no, and that's because an x value repeats. Okay, number 5, one line comes out of each x value, so our answer again is yes, because x does not repeat. One line, one line, one line. That means it is yes once again, because x does not repeat. And our final question, one line, one line, one line, one line. Once again, it is yes, and I ran out of answer choices, so I'll just write x does not repeat. Okay, so you can see here there's multiple lines going to this y value, but that's not important. It's only important that the x does not repeat. Okay, this time we have graphs, and so what we want to do is something called the vertical line test. We'll go ahead and draw some vertical lines through this graph, and we see that each vertical line only crosses in one place. That means this graph, yes, it does represent a function because it passes the vertical line test. Or you could say x does not repeat. That's fine too. Okay, here I'm going to try the vertical line test again, but oh no, look, there are 2 points on this one line. That means the answer is no, because it does not pass the vertical line test. Or you could say x repeats, because this, what is this, -1, x value does repeat. Okay, let's try this one. We're going to do vertical lines, and we see that each line only crosses in one place. So that's another yes, passes the vertical line test. And then number 11, I'm going to draw vertical lines. We see that once again, it is yes, because it passes the vertical line test. Okay, and that just means that again, x does not repeat. All right, number 12, 13, 14, and 15, we have sets of coordinate points or ordered pairs. And we know once again that the important thing we're going to look at are the x values. Okay, so that's going to be the first number of each ordered pair. So I'm going to go ahead and highlight 3, 6, 5, 2. That means my answer is yes, because x does not repeat. They are all different. All right, next question. 9, 8, 9, -7. So when we have ordered pairs, we do want to double check. Okay, this is 9 with 5 and 9 with 3. So that's going to be a no because x repeats, but I do want to add that x repeats with different y's. Okay, because if this were 9, 5 and 9, 5, we could say yes because it's the same point. All right, number 14. Here we go. 11, 14, 15, 0, and 18. So that's going to be a yes because x does not repeat. But this time it's also asking us to find the x-intercept and the y-intercept. I know that I'm going to draw a little graph here. This point represents an x-intercept and this point represents a y-intercept. I know that I need the number 0 in any intercept. So here is a 0 and here's another 0. This is the y value and this is the x. I know that an x-intercept always has 0 for the y, so 11, 0 is my x-intercept. I know that a y-intercept always has 0 for the x, so 0, 7 is my y-intercept. Okay, and then our last one here, -2, 0, -6, 3, and 0 again. Let's double check. That's a 0 with a 0 and a 0 with a -1. Because our x is repeating with the different y values, that's going to be a no. Whoops. And that's because x repeats, and we might want to add with different y. Okay, so now we're looking for the intercepts again. We remember that we need to find a 0 in our ordered pair. So there's one. Here's another one. Okay, for an x-intercept, I know the y value has to be 0. And for this ordered pair 0, 0, the y value is 0. So that's my x-intercept. It's actually also a y-intercept because the x value is 0. And this one has 2 y-intercepts. Here's another one where the x is 0, 0, -1. Okay, so decide if the following tables are functions, explain, then write as ordered pairs coordinate points. Once again, we only need to look at the x values first. Okay, we have -11, -7, 1, -7 again, and -16. So we're going to look here and we see that our x is repeating with different y's. So that means this one is no, and that's because x repeats with different y. Okay, now it wants us to write this table and change it to ordered pairs or coordinate points. I'm going to do a little squiggle because it's going to be a set, and we're just going to copy it with the x and the y value together. Parentheses, -11, comma 3. Our next point is here. That's -7, comma 14. Then here, 125, -7, 36. Big squiggle then. And then our last one is -16, comma 42. It is important that if you're writing ordered pairs, it has parentheses around it with a comma between the x and the y value. Okay, for number 17, we'll do the same thing. 10, 20, 30, 40, 50. So this is yes, because x does not repeat. All the x values are different. We're going to do the same thing again. This time we have a horizontal table here, so that means these are our ordered pairs. It's a set, a group, so I put the squiggle. Then it's 10, comma 1, 20, comma 4, 30, comma 17, 40, comma 1, and 50, comma 8. Okay, circle the discrete graphs below that would be a function. That means we're looking for yes functions. Because we have a graph, we're going to do vertical lines. So we're going to check. Oh no, here's 1 point. That's good. But 1, 2, 3, that is no good. So this is no, does not pass the vertical line test. Here we go. 1, 1, 1, 1. This would be a yes. It passes. Vertical line test. Okay, here we go. We've got 1 and 1 and 1 and 1 and 1 and 1 and 1. So this is another yes. And you can repeat this again here. For time, I'm going to just keep going. 1 line, 1 point for each line. This is another yes. And that is our explanation. It passes the vertical line test. All right, last 2 questions. Create an example of ordered pairs that is a function. So ordered pairs look like this. We would want at least 3. And we know to be a function, we know that our x values all need to be different. So you can do whatever you want. I'm just going to do 1, 2, and 3. And then I'm just going to make whatever. I'm going to use 4 multiple times because it doesn't matter. As long as you have 3 different x values, it is a function. Okay, and our last question, number 20, says create an example of a table that is not a function. That means we need to have a repeat x. A table looks like this with an x and a y, or you could do a horizontal table. We need at least 3. X has to repeat, so I'm just going to repeat it multiple times. I'm going to go 2, 2, 2, and then I'm going to go 3, 4, 5. As long as you have at least 1 repeating x, then that would be a table that is not a function. Okay, I hope this video helped, and stay tuned for part 2.